If you're done with 17, you'll go to 18, but I'll go over each problem here. So part A, we're going to pick the first piecewise because we want x is approaching negative infinity, and that fits by x less than -4. So we know infinity. First thing we do is compare degrees. The degree in the denominator is higher, so we know this fraction is getting smaller, so equals 0. Part B, limit x approaches -4 from the left side of -4. So from left side -4, again, we pick the first one, and we always do direct substitution first, right? So -4 in for x, we get -2/12, we get a number. The function is continuous. There's nothing more to do. Limits as we approach -4 from the right side of -4, that's going to be over here. So the x plus 3, insert -4 in for x, we get -1. That's a real number. Nothing more to do. Right? We only have to worry about a one-sided limit doing decimals if we get like a 10/0, 8/0. There's got to be some indication of vertical asymptote before we even play with decimals. Part D, limit as x approaches 4. Direct substitution. 64/-1, that's a real number. That's our limit. Part E, limit as x approaches 5 from the right. Direct substitution first, we get 125/0. Okay, now we know there's a vertical asymptote. We know the full limit doesn't exist, but it's asking for the approach towards the asymptote from the right side of the vertical asymptote. So we know that the graph is either going to go up to positive infinity. Maybe the graph looks like this. And it's either doing this or it's doing this, right? And now that we're dealing with a decision between two options, the way we can test this without a calculator, without looking at order pairs, is to play with decimals, right? So we choose a number on the right side that we're approaching. So 5.1 in for x, 5.1 cubed is positive, 5.1 minus 5 is also positive. Positive infinity, that indicates that as we approach the asymptote, we're headed towards positive infinity. Part F, we're approaching infinity. So we pick the last piecewise function and we compare degrees, right? First steps first. Degrees tell us the numerator is higher, which means that this fraction is getting larger. And if it's getting larger, it's either heading up towards positive infinity or it's going down towards negative infinity, right? And now we have, we're down to two options. It's either going up or it's going to go down. And then now we can test a number in the direction that we're headed. So 100 into the numerator, we get a positive. 100 into the denominator, we also get positive. So therefore, positive. Part G, limit as x approaches -4. We see that the graph is split on either side of -4. So we look at our previous information, parts B and C. They're not in agreement. So one side is headed towards -1/6. The other side is headed towards -1. They're obviously not pointing towards the same y value, so therefore limit doesn't exist. H of -4 is just asking for the order pair. Plug into x plus 3. We get -1. Page 20, sorry, page 18 is yeah, let's try 2 and 3 here, page 18. we're just going to step through our continuity conditions. And if we see a failure in the second condition, we can stop and say that we're looking at a non-removable discontinuity. But if we pass the second condition and fail the third condition, then we know we're dealing with a removable discontinuity. So let's see if we can practice writing out each of the conditions, see if we can recall our conditions from memory. We see less than greater than, so that's telling us we have to rely on one side of limits. We need to write two limit statements. Direct substitution into both of those expressions. They're obviously not pointing towards the same y value. They're not headed towards the same y value, so we can stop. We know the limit doesn't exist, but we have to provide the justification. Indicate, instead of saying 5 or 17 does not equal to 13, we're going to say that these are not equal to each other. But you don't have to write the expression again. You can just reference them as f of x. But indicate that the one-side limits are not in agreement. Therefore, the full limit doesn't exist. And the full limit doesn't exist. We know there must be a non-removable discontinuity at x equals 1. All right, try number 3. For number 3, though, when we get to the second condition, how many limit statements do we need? 1 or 2? Just 1, yeah. So there's no less than, greater than. Less than, greater than are all contained within this expression. So all we need is one limit statement. First condition passes. Second condition also passes. We evaluate the limit. We get 0 over 0. We know there's a hole, but the limit exists. We factor, reevaluate. The limit is at -2. So we keep going. Third condition, though, we're just looking back at the first 2 conditions. And I want you to write out if they're not in agreement, or whether they're in agreement, you're going to write out the exact same thing, just going to put either an equal or not equal to. So make sure you use the notation that that we've indicated here. Okay, page 21. Let's do 1, 2, 3. Yeah, let's do 1, 2, and 3 on page 21. Okay, first steps first. Don't assume anything. I'm looking for um, your direct substitution as your first step on the test. One root 2 plus 1 root 2 is 2 root 2, but all that is occurring in the denominator. So we want to make sure that we hold on to that 1 in the numerator, 1 over 2 root 2. Number 2 is what value of k, it doesn't say that, but I'll say what value of k will allow this function to be continuous, recognizing that there's probably a hole in the graph. So let's just step through continuity conditions and basically look for k. So infinity. Number 3, find the value for the constant k that will make the function continuous at x equals 0. We're just going to step through our continuity conditions, and before we know it, we're going to be able to solve for k just by going through our conditions. Any questions, 1 and 2? Okay, try number 3. So if we're trying to solve for a missing variable, and you want the function to be continuous, you're just going to go through the condition and make every condition true. So first condition, we have the order pair. Second condition, we're having to go through one-sided limit. -2 and k are the results of the one-sided limits. We need these to be in agreement because we want the second condition to pass. And if we want second condition to pass, we need k to be equal to -2. We want the results to be equal to each other. And by doing that, we solve for k, so we have our answer. Okay, page 22. See if we can do the entire page here, page 22. You can check your progress on the next page with the key. Everybody okay? 6, 7, 6 and 7. Okay, so number 8, direct substitution tells us that there is a vertical asymptote because we're getting 12 over 0. But we're only asking about the movement towards the asymptote from the right side of 3. So now that we're down to either positive or negative infinity, we can plug 3.1 in, test the decimal, and decide which direction the graph is headed. So I get a positive over a negative, so negative infinity. Part B, we're approaching infinity, but if parentheses are getting in the way, you want to FOIL everything out so you can kind of get a clear picture as to what the true relationship is in terms of not only the degrees, but the coefficients. So once we FOIL everything out, we can see, expand everything out. Numerator and denominator have the same degrees. We know there's a horizontal asymptote. The limit does exist, 3/1, which is 3. Number 9, direct substitution will tell you that there's a hole, so you just go through your conjugate process. And you're sketching your graph for number 9. Okay, any questions? Right, last few things, just want to make sure. Page 25, so I went over the the summary sheet already, but just want to kind of go through it again. So here again, here are the topics that you're going to be seeing on your tests. We've been kind of going through each of them, at least doing some of each every day. Yeah, some of the more recent ones, applying intermediate value theorem. I have another problem like that on the morning review on the very last page, I think 27 to 30. So make sure you practice that, know the notations and the justifications that's required. Remember, continuity is a condition. So make sure for all IVT problems that you're stating your continuity, that function is continuous on the closed interval. Horizontal asymptotes, we know that there's a radical in the denominator. We have to, and the degrees are the same, that there's going to be two separate asymptotes on either side of infinities. Comparative growth rates, logs, radicals, polynomial, exponential, and whichever, if the slower is on top and the faster is below, your limit is always 0. But if your faster is on top and your in the bottom is slower, it's either plus or minus infinity, and then you test 100 to see which direction it's headed. And then finally, no squeeze theorem on the test. That was on your quiz, but I'm not going to put it on the test. Okay. And so your review, morning review is going to be page 27 to 30. I highly suggest that you use this as your mock test. And tonight, work through it if you have time. And you can grade yourself on page 31 to 33. And if you do well, then you should feel good going into the test. On page 28, though, if you can omit number 9 is a squeeze theorem problem, so that's why I have it omitted there. And then all the other problems that are also omitted, I've already indicated that on your review. Okay. But tomorrow morning, I'll do a review session going over page 27 to 30, starting at 7:15. It'll be in the classroom, but I'll also send a link, Teams link to you through Remind if you want to join online or join virtually. Okay. All right. So study for your test. Test is tomorrow. No calculator. All right. Come get your phones. Let's figure out. I mean, you can see, but you can go into some, but just do it all in one sitting.
Yes, sir. Okay. Yeah.
1.5A. Yeah, actually 1.5. So it's 1.5 practice. And then the 1.5. 9 through 23. Okay. Yeah, that's right.
All right.
And then you can just spend tomorrow class going through that review.
right.